Have you ever pulled on a cozy fleece jacket and really thought about where it came from? The answer, believe it or not, is probably sitting in your recycling bin. So today, we're going to unravel the incredible scientific journey that turns a hard, crinkly plastic bottle into a soft, durable fabric.
I mean, just think about it. On one side, you've got a plastic water bottle. It's see-through, it's stiff, it makes that crinkly noise, and it's cold to the touch. Then, on the other side, a fleece jacket. Totally soft, fuzzy, and made specifically to keep you warm. They seem like they're from different planets.
So, what's the deal? How is it even possible that these two completely opposite things are made from the exact same chemical stuff? Well, that's the puzzle we're going to solve. And it all kicks off with a secret identity. Right. The link between the bottle and the blanket all comes down to a shared chemical identity. It's one single ingredient that can wear two very, very different hats. Okay, say hello to the star of our show, polyethylene terephthalate, or PET for short. This is a type of plastic, a thermoplastic polymer to be exact, and it's what you find in all those clear plastic bottles with the #1 recycling symbol on the bottom. This is our chemical connection. So try to picture PET as this huge collection of really long repeating chains of molecules. When you line those chains up all neat and tidy, you get the tough, clear structure of a bottle. But here's the magic trick. You can totally scramble the arrangement of those chains to change its physical form without changing the chemistry at all. It's the same ingredient, just a different recipe. So how do we actually do that? How do we follow that recipe? Well, that brings us to the really cool industrial process that takes a bottle from your recycling bin and puts it on your back. This process is just a fascinating mix of brute force and clever engineering. First, all the collected bottles are cleaned up and then shredded into these tiny little flakes. Those flakes then get melted down into this thick honey-like goo. Now, here comes the really cool part. This hot plastic goo is forced through something called a spinneret. And you can basically just picture a shower head with thousands of tiny holes. As the melted plastic shoots out, it instantly hardens into these long, thin fibers. Those fibers then get stretched out to make them strong, and then they're crimped to get that wavy, kind of wool-like texture. Finally, they're knitted into fabric, brushed like crazy to get that fuzzy feel, and sheared to an even length. Boom, from bottle to fabric. Okay, so we know how it's made, but let's get into why it works so well. The coziness of fleece isn't just about the material itself. Nope, it's actually about the physics of trapping air. You know, this is a common mistake people make about any kind of insulation. Fleece doesn't generate its own heat. It's not a little furnace. Instead, its job is to be an amazing security guard for the heat your own body produces, basically stopping it from making a run for it into the cold air. So how does that work exactly? Remember those metal brushes from the factory? Well, they literally tear through the knitted fabric, pulling up the loops of fiber to create this fluffy layer we call a pile. This process creates zillions of tiny air pockets, and since air is a terrible conductor of heat, it acts as a brilliant insulator. Your body heat gets stuck in those pockets, and that's what keeps you warm. Plus, that crimping we talked about, that just adds more volume and creates even more space for warm air to hang out. And on top of all that, fleece has another superpower. It's hydrophobic. That's just a fancy way of saying it hates water. A fleece fiber holds less than 1% of its own weight in water, and that is a huge deal. Why? Because unlike cotton, which just turns into a cold, heavy, wet mess, fleece keeps insulating even when it gets damp. Now, turning plastic waste into clothing, that sounds like a perfect environmental win, right? A total slam dunk. But the reality, as it often is a bit more complicated. Fleece is a true double-edged sword when it comes to its impact on our planet. Let's break it down. On the good side, it's an incredible way to keep a massive amount of plastic out of landfills and oceans. That's a huge plus. It's also way more energy efficient to make than creating brand new polyester from oil. But then there's the bad side, and it's a big one: microplastics. The very thing that makes fleece so soft, those brushed fibers, also makes it shed tiny little plastic threads that end up polluting our water. And to put a number on those energy savings, making recycled polyester can require up to 59% less energy than creating virgin polyester from scratch. That is a massive reduction in its carbon footprint. It's not a small difference. But this brings us right back to its single biggest problem. Because fleece is made of all those broken brushed fibers, it sheds a lot. Every single time you put a fleece jacket in the laundry, thousands of tiny microfibers break off, wash down the drain, slip right through most wastewater treatment plants, and end up in our rivers and oceans. And from there, they get into the food chain. Now, this problem has not gone unnoticed. The race is officially on to create the next generation of fleece, one that gives us all the warmth, but without the hefty environmental price tag. And some of the solutions scientists are cooking up are pretty incredible.
There is some seriously exciting work happening in this space. We're seeing researchers develop biofleeces from things like corn or sugarcane. They're creating brand new knitting techniques that do a better job of locking the fibers into the fabric. There are even new low-shedding weaves that can cut down on fiber loss by up to 80%. And some are even working on biodegradable polyesters that could just harmlessly break down when you're done with them.
And I think this quote really nails it. Fleece isn't the perfect final answer. It's what you'd call a bridge technology. It's a really clever way to make the most of the materials we've already pulled out of the ground, while we work hard on developing something even better. It forces us to think about the whole life of the things we use every day.
Which leaves us with a big question. When you weigh its amazing ability to turn our waste into warmth against its invisible pollution problem, is fleece a brilliant long-term solution, or is it a clever but ultimately temporary fix on our long journey to truly sustainable materials? The answer, well, it's still being written.